Hi, welcome to our presentation on ColorBound. This was a research project at UCF in the Digital Media program by Maxwell Bustamante, James Hiley, R. Mike Livingston, Eric Lovejoy, and Hani Tran. For this project, we focused on UI manipulation through 3 different control schemes. Players went through 3 trials, each with 10 rounds, where they'd have to shoot different colored targets using a gun. This gun would be of 4 different colors, and they'd have to match the gun to the target in order to clear that target. Each trial, they would have a different system for choosing their color. In a second situation, players are allowed to switch between data charts using the 3 control schemes. Those 3 control schemes were the joystick scheme, the translation scheme, and the rotation scheme. The joystick scheme involves selecting a color from a radial menu that appears when the joystick is pushed in a direction. It has a direct analog to the virtual reality game Space Pirate Trainer. The translation scheme involves the player pressing a button that causes a radial menu to appear. Players then physically move their hand in one of 4 directions to choose a weapon. Its direct virtual reality analog is Half-Life Alyx. The rotation control scheme involves the player pressing a button that causes a semi-radial menu to appear. The semi-radial because the wrist can only rotate so far, so we didn't want it to be in every direction. Players then rotate their wrists to choose a weapon. There is no direct analog in virtual reality for this manipulation that we know of currently. Selection for rotation was dependent on controller axis. Pitching the controller forward just causes the axis that is actually tracked for selection to follow. This is based on how OpenXR treats controllers, since this technique just tracks the position of an empty game object made a child to the controller. Exactly where this axis is varies from controller to controller, but it generally follows the length of the controller that is held in the palm of the player's hand. For translation, the axis starts centered on the controller and gradually orients itself to face the HMD. On the axis drawn directly from the HMD to the menu, no selections are made. However, the controller's position is still tracked along it. If the controller moves a certain distance along this HMD controller axis away from the menu in either direction, the system assumes that the player is trying to get a better look at the menu, and it will then recenter the menu to wherever the player's hand is now at. This becomes the new menu origin, and the translation selection tracking continues normally from there. We wanted to test this solution because we felt that current ways of switching weapon types and tools in virtual reality is workable, but in some ways inadequate. We theorized that rotating the hand was an underdeveloped way of making selections in a virtual reality user interface. Our solution was to add a rotation scheme where the player rotates their hand to switch weapon types and then compare the times of how fast it took to shoot the 2 targets, as compared to the translation scheme and the joystick scheme, which are both used reasonably often in virtual reality. We reapplied these controls to a second situation, where a participant can switch between different graphs of COVID-19 data in the United States using the 3 control methods. To create this project, we used the Unity engine, and we used a GitHub repository to allow us to work between multiple people in remote locations. Our game is able to run on Oculus, Windows Mixed Reality, and Valve Index. Thank you for your interest in our research.